Guess who didn't realize he didn't have a video ready to go for Saturday until it was already Friday morning? Certainly not me. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back to 3D Collisions in GameMaker. So, last we left off, I had implemented the last of the 3D collision shapes that I intend on implementing capsules and transform models, and today I'm going to take a bit of a sidestep into the world of 3D collision worlds. Those being just objects that you can add other collision objects to, and you can do collision checks against an entire world of collision objects instead of just individual ones. So, as of the last time I was messing around with collision worlds, I had implemented a data structure known as an octree, which is a way of subdividing a collision world into I want to call them quadrants, but they're really the 3D version of quadrants, what you might call octants. And from there, you can recursively traverse the octree, and you can only have to detect 3D collisions against shapes that are in your nearby vicinity instead of against all the collision shapes in the entire world. And that generally works well enough. There are other ways of doing 3D collision hierarchies, which may or may not be more advantageous in certain situations, more so than others. And I'm going to talk about one of those today. I'm going to talk about the little brother of the octree known as the Quadtree. You can think of the octree as the two-dimensional version of the Quadtree. So later on in the video, I will talk a little bit more about which situations an octree versus a Quadtree might be advantageous. And later on, I do want to make a video on a third type of collision hierarchy, the spatial hash, but I won't, I don't think I'll be doing that today. So right now, I'm in the 3D Collision Test World project instead of the main 3D Collisions GameMaker project that I've been doing most of the work in the series in. And the reason for that is that I want to directly show this in action in the 3D Collision Test World instead of in the very academic, very computer sciencey main project where we're just basically testing a bunch of shapes against each other. So to implement a Quadtree, I can actually really recycle a lot of the code that I've already written for the octree. So I'm just going to copy and paste the call world octree struct, and I'm going to rename this to call world quadtree. And its constructor is going to take the same parameters. It's going to take a bounds and a recursion depth. So the number of subdivisions that we're going to partition the data structure into. And for the most part, all of the methods inside the Quadtree data structure are going to be the same. So the add method, the remove method, the check object method, the check ray method, those are all going to remain the same as they were in the octree. The only one that I'm really going to mess with is going to be the split method. So as I said, a Quadtree is essentially the little two-dimensional brother of the octree, and for my my pictures that I've been occasionally showing on screen to visualize what these data structures are, I have actually been showing Quadtrees this entire time instead of octrees because it is far easier to draw this and represent this in 2 dimensions than it is in 3. But ultimately, the same principle can be extended to 2 dimensions, 3 dimensions, 4 dimensions, 5 dimensions, however many dimensions you want. I'm not sure how many of you are in the business of making 5D games, but the same general rules apply. So that does slightly change the way that we're going to need to partition the world, though. So instead of dividing it into 8 pieces, into 8 octants, as I said, we're only going to need to divide the world into 4 octants. 4 quadrants, I'm sorry. I'm going to be representing the the physical space that each subdivided quadrant in the Quadtree takes up with a 3-dimensional call ab. I'm not going to be doing any 2D shape collisions because, well, I don't want to have to re-implement a bunch of collision detection for rectangles in 2D space versus 3D shapes. You can if you want to. This sort of thing is used in 2D collision systems on occasion. I believe GameMaker's built-in collision system actually uses something very similar called R-trees. They either use R or KD trees. I can never remember which it is. Anyway, for the Octree, we were simply slicing the the bounds of an octree segment in half on the X, Y, and Z axes. And for the octree, we still are going to want to slice the volume in half on the X and Y axes, but we're not going to want to do anything. We're not going to want to change its size on the Z axis, on the vertical axis. I'll get a little bit more to coordinate systems at the end of the video as well, but instead of simply multiplying the bounds, instead of simply multiplying the size of the collision volume by 0.5 on all axes, I'm going to multiply the size of the bounds of the Quadtree segment by 0.5 on the X, 0.5 on the Y, and 1 on the Z, so we're not going to touch the Z axis again. So the vector multiply function can take either a scalar value as its parameter or another vector of the same size. And lastly, the array of children quadtrees that we're going to create. One, I need to have that instantiate a new quadtree instead of a new octree. That's important. And two, we only are going to need 4 subdivisions again. And we are simply going to ignore the z-axis. So we're not going to change the value of anything. We're not going to move any segments up or down or anything on the z-axis. All right, so it's just going to be a new call world quadtree containing a new call add at position center.add new vector 3 negative sides x sides y 0 to the center. The size is going to be the bounds cut in half, the size of the bounds cut in half. The recursion depth is going to be our own recursion depth minus 1. And we're going to be doing that 4 times with negative sides x, positive sides y, positive sides x, positive sides y, negative sides x. That should be a negative sides y and positive sides x, and negative negative. So this is going to be each of the 4 interior subdivisions of the quadtree. And I know I did this on purpose, and I know I kicked myself for it, like, immediately after. But I did hardcode the, like, array size in, down here at the bottom when we traverse the tree. And I don't know why I did that, because I knew I was going to want to talk about quadtrees, which have a different number of subdivisions than octrees later on, and I did it anyway, and I don't know why. But I think that was the only place I did that. I think I either had the foresight to not do that in some of the other methods down here, or I removed the hard-coded value later on. Anyway, so that's all the changes I need to make this work as a quadtree instead of an octree. And before I run the game using the quadtree, I'm going to run the game again with the octree. And I'm going to ask you to pay attention to 1, how long it takes to start, and 2, how long what the average FPS underscore real at the top of the screen is. So I'm just going to run around this the starting area a little bit. You'll notice the whole thing took a couple seconds to start, and it depends a little bit on where I am in the world. But generally, I'm getting between 100 and 130 FPS underscore real from this collision system with all these trees in the collision world subdivided into an octree. And I'm going to ask you to pay attention to how that compares to when I did not time the amount of time it took to start, which wouldn't have been a bad idea. I'm going to ask you to compare that to if I were to create a call world with the acceleration structure being instead of an octree being a quadtree. And again, it takes the same arguments as the octree, so I can just really copy and paste replace call world octree with call world quadtree, and I don't have to change anything else to switch between them. You can even make that a parameter to the constructor if you want to be able to easily swap between which acceleration structure you're using based on what the contents of your world are. And I'm going to do the same thing as I did before. I'm essentially going to run around the boundaries of this collision world, and you can see that the average FPS underscore real is somewhat higher than it was in when we had the octree. We're getting probably, I would say, between about 120 and maybe 160 FPS underscore real at this point, and that's not a bad performance boost by any means. So The reason for that, and I said I would talk about this, is that recursive data structures, the Octree is a recursive data structure, and it does partition the world into equal halves a number of times based on the recursion depth, once each for length, width, and height on the x, y, and z axis. And that makes sense in some 3D worlds where you have a lot of verticality, where you have level geometry happening on the x, y, and z axes. And it makes sense to subdivide the world like that so that you cut down on the amount of objects in each cell in the Octree, in each node in the Octree. But this particular example of this 3D collision world really doesn't have a lot of verticality. We're really only putting geometry on the x and y. If I tilt the camera up, you can see the basic culling, removing a bunch of objects from being drawn, but they still exist in the collision world. But the collision objects really only exist on the x and y axis, and it really is kind of a waste of time to try and subdivide the world on the z-axis as well, because most of those cells, most of those nodes are just going to be empty, and all of the objects are really going to be clustered close together on around like the node that like lies on z equals 0 anyway. And all that extra work of partitioning the world and all that extra work of traversing the vertical part of the Octree really is just kind of a waste of time. And you could see it does take a bite out of the frame time. And again, if you're making something like a level that has a lot of up and down movements, if you're making like a mountainous level or like having the player climb a tower or that kind of thing, it might still make sense. It probably will still make sense to have a Quadtree used in the collision detection.
Hey.
To make use of that vertical dimension to cut down on the amount of shapes in each node. But if you're just making a level like this, which just has a little bit of up and down or even none at all, it really probably will make more sense to use a two-dimensional Quadtree instead. Now, there's a couple somewhat major caveats on that. Firstly, if you're using a Quadtree for 3D collision checking, it really doesn't matter what your game's preferred coordinate system is, whether you're using Y as the game's up axis or Z as the game's up axis or something else as the game's up axis, because the Octree treats all dimensions equally, it treats all dimensions the same. But a Quadtree, you may recognize, does not. My implementation of the Quadtree uses the X and Y as like the horizontal and vertical plane of the collision world, and it simply ignores the z-axis, so it assumes that z is going to be the axis that your game doesn't have anything interesting happening on. But if your 3D collision system was instead using y as the up axis, then this would suddenly become much less optimal. In fact, it would be even worse than using an Octree, because we'd really only be partitioning the world on one of the relevant dimensions plus the up axis, and you'd still have the useless overhead of checking for collisions on a dimension that your game isn't using. Plus, it would be even worse because you'd really only be taking advantage of partitioning the world into one dimension. And I can actually show that off if I were to, instead of using sides.y as the second axis in the Quadtree, I can change that to sides.z. So in this case, xz is going to be the plane that the Quadtree is partitioning upon. Oh, I'm also going to have to change the vector that the world is being resized by. So 0.5, 1.5 for the correct axis. So we're going to run this again, and you can see that performance is actually markedly worse than it was before. We're getting probably 50 to, it looks like about 70 FPS underscore real, compared to, what did I say, 100 to 120 for the Octree. It's actually dropping down to 40, wow, in certain areas. What did I say the XY Quadtree had? 120 to 160? So, definitely if you're going to use a Quadtree, be mindful of the way that you partition your world, because that definitely will have an impact on the performance of what you're doing. So the second comment is that there is a third less related data structure that you can use for 3D collisions, which is the spatial hash. And all of that is what I'm going to talk about next time. So I'm going to end this off here. I'm going to commit this to the 3D collision test world repository, and I'm just going to call this added a Quadtree. And I'm going to mark this commit as, let's call it 0.3a, because this isn't like a final release of the system or anything. And I will also, off recording, I will bring these changes into the main 3D Collisions GameMaker project. And I will have both of those linked in the description of this video. Until then, my name is Michael. I like Wizards and Dragons and making games. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game. Currently a 3D wizard game, which I will be making heavy use of this 3D collision system in somewhere down the line. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I hope you all found this useful, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Gamer Player, Harold Gidry, Manta Ray, Project 103, Rowdy Coder, Sindra Larson, Squarecrow, VTroV, and Zenjament for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.